so I'm coming in sleepy from lunch, and hopefully this is exciting to wake you up a little bit. So VR on the web is like super cool, and I'm set up to work on it. And before I begin, I'd like to engage the audience a little bit. So who here has actually used VR before? A significant number of you, that's really cool. Like every time I ask that question, the number gets more and more and more. Actually, I put it last in 30 seconds, it got more, but just because of people entering the room. So who actually has their own VR headset? Cool, a few of you. I include cardboard in this as well. Like here's the Google Cardboard. Like a significant number. So that's really cool. So I'd like to show today that all you actually need to start working in VR in the web is the Google Cardboard and a smartphone. And I'm guessing those of you with a cardboard probably also have a smartphone. Actually, who here has a smartphone? Good. Okay, at least that minute you are awake. Cool. So, actually, those of you who've actually made something with VR before, like their own. One person, oh, like 3 or 4. That's really cool to see, and I'm really glad to see it. Yeah, so I kind of love VR. I've been like totally obsessed with it since I read far too much sci-fi for kids. And I kind of work with Samsung Internet Security. I work with the Samsung Internet web browser as a web advocate to try and get more people building for the web. And virtual reality is one of those things which Samsung is really promoting. Partly because we have a VR headset. And if anyone hasn't used VR before, want to have a go, I'll be around like all weekend. So yeah, you can come by and have a go. So who actually knew that Samsung had a web browser? More than usual. Okay, yeah, we're surprisingly new. We've only been around for a couple of years and only in a real major way in the past year or so. We're not just the Samsung phones anymore. If you have a Pixel or a Nexus series phone, we work on that as well, and you can download the beta from the Play Store. Cool. So a bit about us. So we're the third most popular browser involved in actually pretty much all European countries after Chrome and Safari. We're a little bit less popular in Bulgaria than most. Usually we're sitting around the 10 to 20% range. But usually you'll see as Android browser drops off, Samsung goes up a bit. So yeah, that's kind of us. But as well as being a mobile phone browser, we've also kind of moved on a bit recently. So we have a desktop browser now, so you can plug the S8 into a dock and it works as a desktop computer. And so we're now a browser which is the same browser on mobile and literally the same application on the desktop. It's pretty cool. I haven't actually got a hand on the S8 yet, so I haven't tested it, but it's supposed to be pretty great. But this is the really cool thing I wanted to show you. So we're also a virtual reality web browser. I think this site in particular, who's familiar with the Space Jam website? Okay, a few of you. It's a bit of an in-joke. It's a really, really old website, and it still works, and it's still there, and it's a pretty fun. But the cool thing about it is that all the hardware this is running on wasn't even like considered when the Space Jam website was invented, and that's kind of the power of the web. Like, you build something, and not only can you support older devices through progressive enhancement, but future hardware running new impressive browsers will, still support your website. And I hope to make a bit of a point of that later. So as well as being an ordinary web browser and VR, we've got some APIs to make it more interesting for developers. So here I've made a demo website which changes the skybox around you. So you can use this to set the environment of your VR experience. It kind of feels more, these are holiday photos I took with my 360 camera. So that's pretty handy. And the other cool thing is native support for 3D and 360 videos. Of course, this isn't a 3D projector, so I can't demonstrate a 3D video, but here's what it looks like when you do a 360 video. So this is built in the platform, it's really performant, and it's pretty fun. So you can do that today in the web, in Samsung Internet. But this is kind of proprietary stuff right now because Samsung Internet is the only VR web browser. Hopefully as VR headsets become more common, we're going to see more normal internet browsing in virtual reality headsets. So hopefully we'll see something come out of maybe HoloLens or that kind of hardware. So this is the kind of what like a 360 image looks like. So if you're dealing with like captured content, this is probably the kind of image format you're dealing with. This is just a normal, very large JPEG, which I took with this camera. It also has videos as well. And it's just a great way to get started dealing with making immersive content. So even if you're not like comfortable with working in 3D environments, it's a good way to dip your toe into VR. So yeah, here's the code for that. So to set the skybox, it's I know this is really horrible. It's a vendor prefix API, and I apologize. But we are hoping to get it standardized as more browsers come around, because you can't get something standardized with only one implementation. Of course, it won't be Samsung Change Sky, it'll probably be long to Change Sky. And for the immersive video, now this is an API I really like because it just extends HTML. And you can do this on a normal website and it won't actually break anything. You don't do any feature detection, you add a dimension attribute, and if it's supported it works, and if it's not it doesn't. This also works in Samsung Internet, that's the normal mobile phone version, and you can pan around and move your phone like a magic window to view 360 video. But all this is really cool and VR related on the web, but it's not specifically what we need to talk about today. So I'm going to talk about web VR, and this is an example of web VR. So I've opened up a website, I click the button, and then it goes fully immersive. This is rendered with WebGL, it's all real time, and it works across, it's not just our browser, it works across Chrome, Firefox, it's coming to Edge, Chrome on Android supports it, there's a polyfill which makes it even work on Safari. I even saw one person get it working in a BlackBerry phone using Opera, using the polyfill. Like, you can use it today in the web, it's really performant, it works really well. And the kind of the workflow for the user is this: you load up the website on your phone or on your computer, you push the button, which puts it into an immersive mode, or prompts you to put the stuff back into your headset. You put the device in your VR headset, and then you're viewing it immersively. So it gives you this really powerful, gives you this really powerful engagement ability, because at no point does the user ever leave your content. They land on your website, and then you're showing them something in 3D. If they're on a mobile phone, they're viewing it like a magic window, so they can walk around and do this. Has people used that kind of experience before? Where, okay, I'll throw the URL later so you can see what that's kind of like. It's basically it uses your phone's orientation sensor, so wherever you point your phone is where you'll see in the virtual world. And when you, and it allows the users to get engaged without actually having to go through the effort of setting up their VR headset. But if they like your content enough and they decide to actually reach into their drawer and pull out their VR or set up their Lighthouse units or PTC5 or whatever they need to do, then they'll get an enhanced experience of virtual reality. And it's pretty cool, and it's all based on WebGL and stuff. So here's kind of the background of WebVR and where it's coming from, and kind of where it's going and what you hope to see in the next few years. So, like I said, it's all based on WebGL, so that's pretty standard in the web now. Who here feels comfortable making something with WebGL? Yeah, like one of you. So, it's a pretty difficult thing to work with. There's lots of really cool libraries that make it easier, and I'm hopefully going to introduce you to a couple later that should make the majority of you feel pretty comfortable working with WebGL to produce something. So in 2012, there was the Oculus Kickstarter. This is kind of what started the modern era of virtual reality as we know it today. So it was based around mobile phone technology with orientation sensors, it didn't use position tracking like a modern desktop headset, but it was the start. It kind of made people take VR seriously again. It's been a few waves of VR, but this one seems like it's sticking around, and I can see the future coming out of this again. So the hardware was released in 2013, and in 2014, a team of Google people and Zillions collaborated to work out like the minimum path to getting virtual reality hardware working with the web. And they came up with the WebVR API. And they've been kind of in development ever since, and there's been a few iterations of this. So unrelated to all this, the Google Cardboard was announced at Google I/O. And in my opinion, this is probably the most important VR headset. Okay, I'm not supposed to say that as a Samsung employee, but it really is. This is kind of what got me involved in virtual reality. When I received my Google I/O, when I received my Cardboard at Google I/O, I took it home and started experimenting with 3.js and managed to hack together a simple VR scene. Like, it wasn't perfect, it wasn't optimized for the headset, it didn't do any distortion, but it was enough to show the power of the web and VR. I could take someone's mobile phone, load up a website, and put it in this piece of cardboard and give it back to them, and they put it on their face and be like, whoa, this is amazing. And I've been ruining Thanksgiving dinners ever since. So, I think the cardboard's pretty cool. It's cheap enough that numerous companies give them away with VR content. New York Times and the Financial Times both have given away cardboard headsets. They're cheap enough that if you want to get started, you should be able to buy one off Amazon for maybe $10, $15 and get started building VR without breaking the bank. So 2015, there was the Gear VR release, so that one. And in 2016, we released Samsung introduced the Gear VR, which was the first and the still only full virtual reality web browser. And it supported the WebVR API out of the box. And along with Oculus, have joined Google and Mozilla in working together, and Microsoft on the WebVR API. So 2016, so late last year, there was the first WCC WebVR workshop where we all got together and started talking about how, what we've learned from building VR on the web, how the APIs need to evolve in order to start being standardized, and whether they're ready yet. And this is a discussion that's going on at the moment. So there's a strong push for standardization from within the W3C and from the community, and we're kind of looking to make sure the standards settle down soon. Because that's the important thing that's happening on the web. Once it's standardized, not only will you build a website that works today, but we'll also work on headsets which haven't even been invented yet. So this is essentially how the APIs work. I'm not going to go into actual code examples because there's no point. The majority of 3D libraries, which are for working with 3D in the web, have now got either WebVR support built in, or it's an add-on you can put in. And also the standards will change over time until it's fully standardized. So I'm going to give you an overview of how it works. So should you choose to implement the WebVR APIs yourself, which you can, they're very accessible, they'll give you an idea of how to do it. So it gives you access to the render loop from the VR headset, because a VR headset tends to run at a much higher frame rate to your web browser. So your web browser will probably run at 60 frames per second, whereas a VR headset might run at 90 or 120 frames per second. It gives you APIs for getting the current position and rotation of the VR headset. Not all headsets have position, so the Gear VR and the Cardboard and the Daydream only support rotation, and it will behave accordingly. using this information, you position the camera in the scene. You can use the gamepad APIs to query the controllers which the users may be holding. Because some VR headsets provide rotation or position tracked controllers you can use to interact with the world. So those are included in the WebVR APIs too. You then use this information to render the scene around them. You render them a pair of controllers if they're available, and then you send this information to the headset using submit frame. The difficult part is doing this 120 times a second. So these are some of the controllers you can work with. So the most fundamental control is gate-based interaction. So this is something like the cardboard, or perhaps for the Gear VR or the Daydream when the user doesn't feel like using a controller or perhaps can't use a controller for whatever reason. So these are the kind of interactions where the user looks at something and either it counts down for a bit and then triggers something, or if they tap to the side of the controller or use one of the controller buttons, it engages with that content. And this is like the fundamental thing it's good to support. Like if you're going to do VR on the web, your experience should probably support this kind of interaction. If you absolutely must force the user to use a controller, then probably some kind of traditional gamepad. It's got good support in most browsers. It works really well and gives them an experience which allows them to move around the scene without having too much difficulty, because it'll be a layout they're familiar with. The 3 degrees of freedom controller is the kind which was recently announced for the Gear VR, the one that comes with the Daydream. So you can use it like a laser pointer to point at stuff, but you can't use it to go out and grab something. But it does give like the first level of physical immersion. The 6 degrees of freedom controller is probably what you're familiar with if you use something like HTC Vive or an Oculus Touch. Those 3 of you in the room. It gives you a full position controller, so you can actually reach out and grab stuff in VR. It gives the user a really natural experience. So if you can support gate-based interaction in that as well, you'll give people a really great experience on mobile, which will get progressively enhanced when they're using a desktop version of WebVR. And finally, the most immersive one is actually just tracking the user's real hand. So this is the kind of tracking you get in the HoloLens or you get with the Leap Motion. And it's very, very cool, but very rare. There's not many people can afford HoloLens, and setting up the Leap Motion on to work with mobile can be a little bit difficult in the web. So yeah, if you're doing tracking correctly and you've got it all done and all set up, this is the kind of what you get. So I've just got a pass-through camera showing you what's happening in the real world and in VR. It kind of matches exactly. So what you're really doing is doing like a matching you're overlaying a virtual world onto the real world and showing that to the user instead. By combining it with 3D audio, you can give them a real incredible feeling of immersion, even on lower end headsets. Yeah, so here's where it's currently supported. So on Firefox and Chrome on the desktop, it works with the Oculus Rift and HTC Vive. So they're like the 2 big ones on desktop. For Samsung Internet, for Gear VR, works with the Gear VR. There's also the Carmel browser, which was announced recently. Still in beta, but it's available for Gear VR. I think you can find it in the store and have a go at some of the demos. Edge is working on HoloLens support for the WebVR APIs, and I think that's going to be incredibly powerful to users. And on mobile Safari, you can use the polyfill. Well, on pretty much any mobile browser that supports the orientation sensor and WebGL, you can use the polyfill. The polyfill actually gives incredible performance. You'll get just as good results using the polyfill as pretty much you will natively. So this has all been quite academic so far. I've just gone over like what you can do. So here's some tools which are useful for actually building stuff. So who here is familiar with Unity? So quite a few of you. So yeah, this is Unity is what most 3D developers are familiar with. There isn't many. So there is They are looking at improving WebVR support, and I think there is a library out there which integrates with Unity to allow you to compile WebVR support infinite to work on the web. 3.js is a JavaScript library for working with WebGL. So who is familiar with 3.js? Cool, a decent amount of you. So if you like working with JavaScript, 3.js takes a lot of the headache out of working with native WebGL. My personal favorite one is A-Frame. So A-Frame is built on top of 3.js. It uses W3C web components to make HTML elements which render as 3D, and it works with WebVR out the box without you needing to do any setup. It's really cool. If you like Unity and want something more web focused or something more targeted at the web, Play Canvas is a website which allows you to build a 3D scene which works with WebVR and very performance and very graphically impressive. I've got a demo of it later. So, quickly show you what A-Frame is. Actually, who has heard of A-Frame before? Yeah, so a few of you. If you're familiar with HTML and you really want to start working with 3D stuff, A-Frame is where I recommend you start, because it looks like this. This is full HTML file. I include the library, and then I just write HTML, which describes the scene. So in this example, we describe the A scene, which basically tells the browser, yes, I want a canvas, I want some light, I want a camera. Just set it all up for me. So these are all stuff you can override if you want. So at no point are you locking yourself into certain expectations. It just works. I've defined a sphere with a color at a position, a box, a cylinder, a plane, and a skybox, which is just gray. So I'm hoping that seems pretty friendly. But yeah, it's pretty powerful. So you get something that looks like this. Because I'm a weirdo, it's actually an iframe and works in my slides. There you go. So by default, out of the box, I get mouse support, so I can click and drag. I can walk around using the BWS'17. If you open up this URL on your phone, it would push that. Yeah, you'll open your phone, you'll get the magic window experience, where it looks like you're using your phone as a magic window to look into this environment with these three primitive shapes. You press the VR button. It'll use the polyfill to make sure it works with cardboard. If you're in a WebVR compatible browser, or you have the hardware plugged in, it will work with your expensive VR hardware as well. So, from what was that, like 9 lines of code? I think that's pretty good. So yeah, that's pretty cool. But why do VR on the web at all? I mean, if we're being honest here, the web is acting as another abstraction layer on top of virtual reality. And you can't have an abstraction layer without a performance cost. And yeah, there's no magic potion here. Yeah, there is a slight performance cost of working on the web. You have, for example, WebGL 1 isn't the full OpenGL which modern developers might be used to. WebGL 2, which is equivalent to OpenGL 3.2, I'm not very good at version numbers. But WebGL 2 should help with this, but WebGL 2 isn't widely available yet. It's something that's only just starting to be rebrowsed at this point. But the web gives you far more than this marginal performance cost, because the web gives you this ability to land someone into a scene and get engaged with your content straight away. They don't need to download anything or set anything up. It's ready for them to start using right there in their browser. And even if they haven't got a VR headset with them, then they can still click and pan around and engage with your scene in a way that's compatible with the device they're using. I mean, this is the web we build progressive enhancement in from the start. I mean, yes, you can build a WebVR experience which is a giant download to show the user a loading file and will only work, and you can throw an error message saying, oh, will only work on HTTP. But that's not web life. It's not what we should be doing. And the web gives you the ability to build like that from the start. The other powerful thing about it is that sharing content is easier than ever. Because all your users have to do is copy and paste a URL. So in all these demos I've shown there's been so far, these have all been loaded from scratch, from an empty cache. These weren't just something I preloaded and stored in Service Worker. Actually, that last demo was stored in Service Worker because I'm not on the, I'm not actually connected to the Wi-Fi at the moment, but it's the kind of thing where you can load stuff up quickly and show it to users and get them engaged. But you can rely on this new technology the web's providing. Like, you can build a progressive web app, which is also web VR. Like, it's all the really cool stuff that's coming out of the web and all these cool APIs like web MIDI or speech synthesis or voice recognition. You can use these JavaScript APIs to enhance your web VR experiences. I think it's really powerful and really cool. And once these APIs are standardized, you can build it once, deploy it, and it'll work. It should work on all hardware that supports web VR, and it'll work on new hardware that starts supporting web VR as well. And with this performance cost, I think it's a small price to pay, because if visual fidelity was all that mattered, we would be watching Blu-rays and not Netflix. I mean, let's be honest here, who here watches Netflix? Or some equivalent like YouTube or Hulu or something, yeah. Like significant number. Who here watches Blu-rays regularly? Yeah. One person. Like, accessibility to content is far more important than any kind of just raw graphics. And as devices get more powerful, this becomes even less of a concern. How you design something is far more important than just the amount of polygons you can program. So when you're building with the web, yeah, it comes with expectations. Even if you're building something really cool with VR, and you tell someone, yeah, this is really cool, they'll probably wait a bit longer, because yeah, I've never seen VR before, let's see what this is. But they're still not going to wait that long. If you give someone a 3-minute loading screen as you download 100 megabytes of content, they're not going to do it. They're not going to actually engage with it at all. So what you need to do, you need to start showing content from the moment they land on the page. It's more important to be fast than be complete. So what's quite a nice tactic is actually download a blurred, low-resolution skybox and show that within 500 milliseconds landing on the page. And then at least they're being like, oh, it moves my phone, it might encourage them to look around a bit more. And you can basically use this to keep bringing in new content. Each time more content comes in, they'll give you more of a chance to let the rest of your content load. And you can build up the scene around them. You're not after some kind of fully realized 3D game from the first asset. If you do need that kind of control and that kind of ability to have large amounts of content pre-cached, the web is probably not the best place to do VR for you. Like if you're building a game to come weighs in at 4 gigabytes, there's APIs in the web to allow you to store large amounts of data, but not that much data. Or if you do, the browser will probably evacuate it from the caches pretty quickly. So yeah, it's not good for everything. The kind of stuff it's really good for is for shopping, so showing people what their hotel's going to look like, the new house they're going to move into. Showing someone the furniture they're going to buy in real scale so they can make sure they're not buying dollhouse furniture. You can give people these kinds of experiences. It's great for education when you can't have a high-powered desktop computer for everyone in the classroom, but you can let them use their own smartphones with the Google Cardboard to engage with them. You can take a school class on a field trip to Mars with VR. And it's the kind of thing where you can stream in 3D videos or add assets to it to work with it. It's pretty cool. So definitely not for everyone, but for the majority of use cases, I think it's good. So this is a demo, again, cold cached on a throttle 3G connection. So there was content within a few seconds, but not all the content was downloading. Was downloaded. So as the user browses around, more content is being downloaded in the background. So this lets the user engage with it without having to look at the loading screen for ages. Because you can build the best VR scene in the world, and if the user has to look at the loading screen and get bored and leaves and never sees it, you just wasted a ton of money. The advantage of WebVR is being able to reach the widest possible audience you can with WebVR. There's a wide variety of hardware out there. So you're probably going to be wanting to aim your VR content at mobile first, and then progressively enhance it to desktop. So, because if you make your content look great and fast on mobile, it will also look great and be incredibly fast on a high-powered desktop computer. And you'll just need one deploy for this. Like, you don't have build a mobile VR site and a desktop VR site, you just have the one. And then if you seem to have lots of spare time left in your render loops, then perhaps try putting down high resolution content, more detailed models, perhaps compile some more advanced shaders. There's all kinds of stuff you can do. So progressive enhancement is just as important in VR as it is in the traditional web. Mobile first is more important here than ever, because as we probably all here know, mobile browsers recently overtook desktop browsers, and there's no place that's more true in VR. There's been 5 million Gear VRs sold. There's been tens of millions of cardboards out there in the wild. We're probably looking at hundreds of thousands of desktop browsers, of desktop VR equipment. So it's important you build it mobile first and then enhance this for desktop. Again, with controllers, as I said earlier, make sure it works for game space. A lot of people probably won't have a controller, but if you can enhance it with support for a 6-degree freedom controller, fantastic, do it. It's a really great thing to do. Cool. Yes, that's some time left over. So, sorry, I was rushing through this a bit because I've got something really cool to show you. So, this is something which a developer called Jerome Etienne is working on, and it's not web VR. It's augmented reality on the web. So it works on any phone which supports the orientation sensor APIs and the WebRTC video support. And it allows you to do augmented reality in the web incredibly quickly. So here I scan a QR code, which is on the marker itself. So it scans and it reacts to it. It then loads the website in only a few seconds. It asks for permission to use my camera, and then boom, augmented reality right there. Yeah, and this was just taken on my phone like last night. So this is real-time augmented reality at 60 frames per second in a mobile web browser. Yeah, it's a really, really awesome demo. This is, so it's libraries called AR.js. There's a version of it that works with A-Frame. So if you're just getting started with VR in the web and want to give it a go with A-Frame.io, then yeah, you can do augmented reality with that, which I think is really, really powerful. Well, move on so you don't see my notifications. So yeah, it's really important that you get involved with the standards for this. So if you want to start building things with web VR and really try and push them to their limits and try something that's never been done before, please do it and feedback in the standards process, or at least build something and see what's going to happen. It's a really great time to get involved. The standards have not been finalized yet. We're still working out how we can do support for HoloLens really well and get everything working in a way that's going to be robust and last long into the future. Like, we don't want to build another app cache where it's useless after a few years. This needs to be something which will last long into the future of augmented reality and virtual reality and even mixed reality content. So please get involved. Please give feedback on this talk so we can learn and improve, and also it helps get me speaking at more conferences. And if you have any questions, please ask, and thank you for listening. I think I should have had some time left over.
Okay, thank you, Ada. Who wants to be first? Hey, then I guess I'll be first. You talk about virtual reality, and the previous talk was about accessibility. So, don't the two conflict with each other? How accessible is VR today?
Thank you for asking. Yes, I actually have very strong opinions about this. So yeah, web VR right now is not accessible. In my opinion, that is not acceptable. You can probably make a web VR experience accessible by integrating it with the speech synthesis API, but I don't think a programmatic approach to VR is a web-like approach. The main advantage of the web is that if you build something using normal HTML and CSS, you're going to be 90% accessible out of the box. But if you build something with web VR and just using normal web VR tools, you're going to be 0% accessible out of the box. And that's not going to work. So tools like A-Frame, which give you, or VRML, which give you declarative HTML, declarative VR, I think is going to be the most important thing for the future. So right now, web VR is like the shortest route to getting VR in the browsers, getting VR working in a web browser. But I think if we're going to have a healthy virtual reality web for the future, there's going to need to be some standardized integration with virtual reality. So HTML elements that work natively in a VR headset and enhance the experience for everyone. So I think that's going to have to be the future. Whether it comes out of a third-party library like A-Frame, making itself more accessible, or whether it becomes part of the web platform itself, I do not know. There is a community group called the Declarative VR Working Group, community group, which are having these kinds of discussions. And these are the kind of discussions we were having at the WCC workshop as well. So it's definitely something we are aware of.
Okay, thank you. Next question.
So, do you think that in the future, augmented reality will become more popular than virtual reality because it doesn't disconnect the user from the real world?
Yes, that's actually my personal opinion, that virtual reality is kind of a stepping stone to whatever the future is going to be. I think it's going to have great value in determining the user interfaces we develop and the control system, how people interact with the world. Virtual reality is this space, this very greenfield space for design right now, because there's no standardized user interfaces for virtual reality. There's no hamburger icon for virtual reality. There's no button that works all situations. There's no A tag for virtual reality. Sure, you could manually change the location.href when they put a ball on their head, but there's no standardized pattern for that. So I think VR is going to have lots of value in determining how that comes about in the future, but I'd like to see our day-to-day usage of the web in some futuristic environment where we all got augmented reality headsets being one which we can all just work with the normal web as we do today on our mobile phones. And I think it's going to have to grow accordingly.
Thank you.
Hey, thank you for that talk. I have a question following on from that. If the future is augmented reality, we all have augmented reality headsets and we're streaming all of the information that we're seeing onto a web server somewhere owned by a company like Google, for example. We're giving them a lot of information, right? We're showing them the room that we're in, we're showing them the people that are in the room with us. Do you know of any ethical considerations that are any conversations that are being had, any frameworks for this? Because this is a huge amount of information, and new information that they didn't have in the past that we're giving them.
Yeah. So, yeah, it's a great question. And I think this, right now, in the web platform, we're trying to get everything, including augmented reality, like AI.js, work in the browser. It's not sending information off to a third-party service. It's done on your mobile phone using your phone's CPU. Same with the VR environment. It's just a static web page. Like there's no more concerns than you would have browsing the web normally. There's still the web security sandbox. Security is something we're very aware of. For example, if you notice, you have to click on a button to enter VR, because at no point we want someone to land on a VR website and have it totally imitate their browser and put them into like a virtual world where it emulates their browser to try and get given information away. So security is definitely one of the foremost considerations in these APIs. And the stuff which might be a bit more difficult is actually one problem with that kind of accessibility needs. Because one way in order to make a VR scene accessible would be to stream the rendered content to a web server, to do image recognition on it, to tell the user what's happening. And that can be very dangerous for users, especially people who, and this will especially affect people who actually need this information the most. So whether Moore's law is going to simply mean that we can do the image recognition locally on the device, or whether we're going to have some method to mark up scene descriptions into the virtual reality scenes we build, is something I don't know, and a problem that needs to be solved. And I think it's a problem that will be solved along with the accessibility concerns of VR.
Okay, we have time for a last question. One question only. Okay.
By the way, thank you everyone for the amazing questions. I mean, like stuff I love to talk about at the moment.
I don't think it's too early. This is a different kind of question.
Okay.
Is there support, do you know, in the WebVR standards for digital terrain models?
So the WebVR standards are, they're nothing to do with rendering. It's just about getting information from the headset and from the controllers and sending pre-rendered data to the headset. Same with WebGL. WebGL is totally model format agnostic. It doesn't care. All it cares about is you tell it to render some triangles, it will render some triangles. If you look around, there might be importers out there to allow you to import 3D terrain data into 3.js or into A-Frame. I've definitely seen lots of terrain models in WebGL, so I'm pretty sure people are working on this. But if it's not out there, then yes, you'll have to write your own importer, as you have to write importers for every 3D format that's used in the web today. But because the large amount of the web is open source, if someone has done it, it's probably out there and ready for you to use.
Okay, thank you very much.